In this video, we are discussing parent functions and transformations. Our objective is to define a parent function, to be able to state the transformations that have been made from a parent function, and to rewrite a linear equation in slope-intercept form, which is y equals mx plus b. A parent function is the most basic function, and it is used to build new and similar functions. The linear parent function is defined as y equals x. If we take a look at the parent function, the slope is the coefficient or the number in front of the x, which is 1. In this case, then we can write it as 1 over 1 or just 1. The rise is 1, the run is 1. The y-intercept, we don't see anything after the x, which would be 0. So our y-intercept, our x value is always 0, and we will cross the y-axis at 0, meaning that our y-intercept is at the origin. So if we are to graph our parent function, we'll first put a point at our y-intercept, which is at the origin 0, 0, and then we go up 1 and over 1 to make our new point, and again up 1 and over 1 for another point. Then we draw our line, and this will be what the graph of the parent function looks like, our basic linear function. So, how can we change the parent function? What can we do to it? Well, we can change the slope, or the rate of change. And when we change the slope, what we're doing is changing the direction of the line. When we change the direction, it might change from positive to negative or negative to positive. So we might be changing the direction. We also might be changing the angle of the line. The angle of the line may change to be more steep or more shallow than the parent function. The second thing we can change when we're talking about the parent function is the y-intercept. When we change the y-intercept, which is the starting point of our line, we may change it to be above or below the origin. So when we change the y-intercept, we may be shifting the line up, or we may be shifting it down. We call these changes transformations. We're transforming the line. Let's look at an example. Here we have the equation y equals 2/3 x minus 4. If we were to make a table, we would want to have our x values and our f of x, or our y value. We can either put it into f of x function form, or we can put it as our y, or our output. So let's put a couple values in. Let's say we put in the value of -3, 0, and +3. The reason I picked those values is because when I multiply my slope times, since it is a fraction, times a number that is a multiple of the denominator, then that will get rid of my fraction and I don't have to graph fractions. So if I put a -3 in here and have -3 over 1, and I multiply those together, I'm going to get -6 over 3, which is -2, minus 4 is going to give me a -6. When I plug in my 0, 2/3 times 0 is 0, and 0 minus 4 will be -4. And then when I plug in a +3, I'll have 2/3 times 3 over 1, which gives me 6 over 3 or the value 2, and 2 minus 4 is going to give me a negative 2. So let's graph. So I have negative 3, negative 6. I have 0, negative 4. And I have 3, negative 2. Be sure when you graph the lines that you draw in the x and y axis, labeling them x and y, and mark an appropriate scale. If your scale is going by ones, you don't need to mark that. We will assume it's going by ones, but if you'd like your graph to go by 2s or 4s or 5s, etc., then we'll want to make sure you label accordingly. So we want to compare and contrast our graph or equation to the parent function. Remember, our parent function is y equals x. That's our parent function. So we can see that we are having a different slope. The slope of our parent function is 1 over 1. The slope of this function is 2/3. I'm going to draw my parent function onto the graph so that we can compare. Notice a couple of things. First of all, our angle of our line didn't change. Both of them are going to have a positive slope. Secondly, we take a look at the angle of the line. We can see that the blue line, our function, compared to the red line, the parent function, is not as steep. It's actually shallower. And the last thing to look at is the y-intercept. The y-intercept of our parent function is at 0, 0. Our new y-intercept is at negative 4, which means that our new function has shifted down 4 units. Let's take a look at another example. The first thing you might notice is that our equation is not in slope-intercept form. We need to rearrange this equation and put it into slope-intercept form. So the first thing that we need to do is to move the 7x. So we're going to subtract 7x from both sides of our equation. So we have 2y, and writing this correctly in slope-intercept form, we want the x's first, negative 7x plus 4. Now what we're going to do is we want the y by itself, so we're going to divide everything by 2. And so we have y equals negative 7 over 2x. That is reduced, so we're going to leave it as a fraction because our slope is rise over run. And 4 over 2 can be reduced to 2. Alright, so let's put some points in the table. Here we have x, and we have f of x, our function, which is also our y value. Again, I'm going to put in 3 different values, and because I have a fraction for my slope, I am going to use the common denominator or a multiple of that so that I don't have any fractions when I'm graphing. So in my table, I'm going to use a negative 2, 0, and a positive 2. So when I take my negative 2 and I substitute that in for x, I have negative 7 over 2 times negative 2, which is over 1. So I get a positive 14 over 2, which is 7, and 7 plus 2 is 9. When I put in my 0, I get negative 7 over 2 times 0 is 0, and 0 plus 2 is 2. When I put in a positive 2, that will be the same thing as this fraction, 2 over 1, except it will be positive. So I'm going to get negative 14 over 2. let me show you just to make sure you understand. Negative 14 over 2, which is negative 7, and then negative 7 plus 2 is negative 5. Alright, so we want to graph these 3 points on the coordinate plane. Here are the 3 points graphed on the coordinate plane. Now we're going to draw our line to connect them. We've drawn a line to connect the 3 points together, and now we need to compare our new graph to our parent function. Remember that our parent function is y equals x, where our slope is 1 and the y-intercept is at the origin 0, 0. So if we compare, the first thing that you should notice is that the line has changed direction. It is now a negative slope, so the angle of the line has changed. Secondly, you would notice that the line is more straight up and down. It is steeper, even though it's going a negative direction as compared to our positive direction. It is much steeper. Lastly, the y-intercept is at a positive 2. Our line has shifted up 2 units because our y-intercept is at a positive 2. Let's do one more example. Again, the first thing that you should notice is that our equation is not in slope-intercept form. So we need to put that into slope-intercept form. The first thing we're going to do is to distribute. So we're going to take 3/4 times x to get 3/4 x. And then we're going to multiply 3/4 times 12 over 1. When we do that, we get 36 over 4, which is 9. Next, we need to get the y by itself, so we're going to subtract 3 from both sides. So we get y is equal to 3/4 x plus 6. Now we want to put some points into the table. So when we do that, we have our x values and our f of x, or our y values. Again, to help you out, if you would multiply by the put in x values that are multiples of the common denominator, you will not have fractions as your output. So we're going to put in a negative 4, 0, and a positive 4. So when I plug in a negative 4, I'm going to take 3/4 times negative 4 over 1, which gives me negative 12 over 4, which is negative 3. And negative 3 plus 6 would be 3. When I plug in a 0, 3/4 times 0 is 0, plus 6 would be 6. And then if I take 3/4 times a positive 4 over 1, that's 12 over 4, which is 3, and 3 plus 6 is 9. Now I want to graph these 3 points in the coordinate plane. After I graph the 3 points, I want to draw a line to connect them. After we've drawn our line, we need to compare our new function to our parent function. Remembering our parent function is y equals x, where the slope is 1 and the y-intercept is at the origin. First of all, if we compare, we know that our parent function had a positive slope as this one does. So they are at the same angle, both have a positive slope. You will notice that this line is not quite as steep, so it is more shallow than our parent function line. And lastly, our y-intercept is at positive 6, so this line has shifted up 6 units from our parent function. I put the parent function on again in a red line for those of you that might need a comparison. Again, it's at the same angle. Our function is not as steep, it's more shallow, and it has shifted up 6 units from the parent function. So to review, the parent function is y equals x. Our new function can have several transformations. It can be more shallow or more steep than our parent function. It can change direction from positive to negative or negative to positive slope. And the entire line can shift up or down. Please remember to complete the reflection.